Transportation. Whether you like it or not, it's just one of the main things that you use throughout your life. From taking the bus to school, riding your bike to the shops, or the long, agonizing trips to relatives' house. These are all things humans have just adapted to, but have they ever wondered what could be the future of transportation? Here, we will be talking about the positives and negatives of potential future cars, and the potential solutions for using more efficient cars. We believe that electric cars are the solution, and we'll be talking about the pros and cons of electric cars.
Currently, the majority of Australia's power comes from fossil fuels, as they account for over 70% of the country's energy supply. If we wanted to run a car that runs off clean electrical energy, then it can be counterintuitive. So we wanted to find how much electrical energy we would need to put into an electric car. So we used Isaac Newton's second law of motion, where we can calculate a force, mass, or an acceleration. In this case, we wanted to know the force to find out how much energy we would need to accelerate our 1,000 kilogram car to 100 kilometers an hour. So we put in the numbers, converting kilometers to an hour, with meters a second. The second law of motion is F equals ma, or in our case, F equals 1,000 times 27.7 repeating. And that simple equation gives us around about 27,750 newtons, which will be rounded to 28 kilojoules. So it takes around 28 kilojoules of energy to accelerate a 1 metric ton car to 100 kilometers an hour. So what does that mean in terms of fuel consumption? In a kilogram of diesel, or 1.25 litres, there's 48 megajoules of energy. If you had enough gears, you could theoretically get up to 48 kilometers a second with a kilogram of diesel. Of course, you cannot get up to 100,000 kilometers an hour in your BMW. Generally, you lose 75% of your total energy to heat, and so you only get up to 25,000 kilometers an hour. And among other losses like air friction and then friction on the axles and importantly brakes, we end up with a far inefficient car. And then we can only get up to 15,000 kilometers an hour. Then that's nice. How does the electric car fare with its batteries? In a kilogram of lithium-ion batteries, they have anywhere between 400 kilojoules to 800 kilojoules. Usually, diesel is 100 times more dense in energy. Plugging in numbers again with a 600 kilojoule battery, we get 600 meters a second, or just breaking over 2,100 kilometers an hour. Though the diesel's batteries dwarf the electric cars, it's only by a slight amount, and the diesel cars lose a ton of energy to heat, making it dead inefficient. Electric cars have better acceleration compared to its competition, as you can just tell the motor to accelerate the whole car and it just moves. Diesel cars with their gears have to go to 10 kilometers an hour, and then change gears, and then 30, and then so on and so forth. In internal combustion based cars, which is what a diesel car is, you need a fuel tank, battery, exhaust, and so much more. And every new part means another part that can break and stop the car from working. And these parts can be very costly to replace. So it is clear why the electric car struggles. At best, it stores 1/8, and at worst, 100th in terms of energy of what a diesel car can. To compensate, you have lots of batteries in your car, enough to store 60 to 100 kilowatt hours, and lots of bases where you can fill up and charge your car. Now, how can we improve? A good candidate for a good idea is to add a solar panel on top of your car, or any way you can, as this will increase the battery life of your car. If you had a meter squared surface area of a solar panel, then you would produce 150 watts of energy and thus increase your battery life. But then you'd have to lie your solar panel flat on the roof, which would make it lose about 70% of your total energy, making the solar panel only then produce 35 watts of energy. To remedy this, you will need to point your solar panel up and towards the sun. But you can't do that because you'd either lose the solar panel entirely, or you'd increase your drag, lose more kinetic energy, basically nullifying this effect. Another pro about laying your solar panel flat is that you don't need to worry about which way you need to point it, as it points to the sun equally in every single direction. If you point it in the direction that you're driving, then the sun could hit the back of it, and with better applications of science and math in geometry and algebra and more, we can make electric cars viable as a business and take over petroleum-based cars with a cleaner and better future society with the help of maths.